Hi everyone, my name is Caesar, also known as Lego Caesar. Today I want to share with you something extremely special, groundbreaking, and simply super awesome. I will be giving you a walk-around tour of a remote-controlled airplane built completely out of Lego, the X-3 Ghost. Okay, so a few points of clarification. First, by completely out of Lego, I'm referring to all of the functional components, which include structural, mechanical, aerodynamic, motors, and electronics. The only thing that is not Lego is the skin. Second, right now it's technically a glider because it doesn't have a motor to propel it, because Lego doesn't make anything with enough power. And third, Lego RC components have an extremely short range, so even if this plane had a motor to propel it, it's basically impossible to control it. We really need them to fix all of that. Now I want to show you the systems of the Ghost in detail. The whole airframe is built on the special proportions of a 3-4-5 right triangle. In these main lines that become 60 studs, 80 studs, and 100 studs. The important thing about this ratio is that it allowed me to easily build reinforcing structures inside of it, like these 6, 8, and 10 stud triangles. The next part of the structure is the main wing spar, which depends on these rectangular frames to save weight while making the spar very strong. Lastly, as far as the structure, we have these H-frames that I use to make the spine. These make for a really light but robust central column. The mechanism for controlling the elevons is really simple, and intentionally so. These are the main control surfaces, so the less complicated they are, the less there is to break. We have the servos right inside the wing, with the power only being transferred by this U-joint and these two gears. The mechanism for raising and lowering the landing gear starts here with this medium motor connected to two clutches to carry the load. Through these gears, the shaft inside the spine is driven, delivering power to the linear actuator in the front and two in the back, one on each side. Each of the linear actuators is then connected to the struts which support the landing gear. Aerodynamically, the contours are suggested by the structural frame. The rest is done by the skin. But the main thing about this design is that my goal was to maximize wing surface area for the weight of the aircraft. That's why it's more of a delta or flying wing design. And of course we have the two control surfaces to steer the aircraft, which are independently working elevons, meaning that they function as both elevators and ailerons. Motors we already covered, but let's look at the electronics. Everything starts with this rechargeable Lego battery, which is great for this purpose because it's light and easily accessible for recharging. The battery has a low power output, but we're not using it to propel the vehicle, so it's sufficient. The battery is then connected to two infrared receivers in the back. Unfortunately, they have an extremely short range of only 30 feet, and that makes flying this aircraft pretty much impossible. Almost impossible, but we're gonna do it anyways. One of the receivers is used to control the elevon servos, that's the one on the right, and the other one controls the landing gear motor and a set of lights. The last electronic component is this controller, which is a combination of two different remotes. This one is used to fly the aircraft, while this one is used for the landing gear and lights. Okay, so that's it for the description, but we still have to see how it all works. Okay, thanks for watching everyone. Please like, share, and subscribe for more awesomeness.